we are in Korea, in Busan, in the backyard of our Airbnb. And this is because Felix is presenting right now on the World Barista Championship stage. He's the German Barista Champion, and he found something very spectacular in his preparation. In this video, we are going to talk about coffee waving, an absolutely new and innovative method post-extraction to make espresso better. But we are not only talking about it, we are talking with two professors who did some research together with us, and we will present you our results. Right now, Felix is presenting on the world stage of the World Barista Championship as the German champion. And not only Felix is here beside me, also Nicole, a multi-winner competitor from Germany, Coffee and Good Spirits, Barista Championship, but also Brewers Cup, and also, very successful on the World Barista stage. Nicole, you are the coach of Felix, accompanying him during the presentation, and you both together found something new, something spectacular, which made coffee better. Actually, you found it, Felix. You have been pulling some shots, and then you found something. Can you tell us a little bit more about how this process happened?
Yeah, so I organized myself a vibrating plate because I saw it last year compared to using it for pack preparation. So I want to try the same, but in my way it didn't work at all. So I thought, what can I do with this vibrating plate instead of pack preparation? And then I placed my pulled espresso shot on this vibrating plate, and I found out that it actually changed a lot, and it was changing even more than stirring your coffee. It was I was a bit unsure if it's like me after hours of training thinking just that it's better. So I start to ask a lot of people, do you taste it different? And all of them found it different.
Yeah, we even did some triangulations. We asked many people, and we all found, well, this espresso is way better, not only better than the not steered one, but also as the steered one. And it's better in a certain way. What do we taste if we vibrate, or as we say, wave the coffee, Nicole?
It's really interesting because as Felix found it out, he told me, and I was like, yeah, of course, like it absolutely makes sense. You're really mixing all of those molecules and the soluble and non-soluble matter that you have extracted together, which due to the temperature instability actually in espresso, because it's cooling down, you have different behavior of the espresso and the solubles within this drink, which makes it quite hard to get one consistent expression of this coffee. That's why usually we say like drink it in 3 sips and 2 sips, however. But by putting it on this vibration plate, we can achieve 2 things. We can really create a very even distribution of the particles in the espresso, which gives us the impression of a very smooth, round body. We have an improved tactile. And the other thing that we're improving is the acidity can go down, which helps us to create a very clear fruit expression. So let's say you have passion fruit. Sometimes the passion fruit can be quite astringent, but with the coffee waving, we get a very clear passion fruit note out of our coffee. And last but not least, the hyperoxidation that happens at the surface also helps us to get a more stable cup.
Absolutely.
So all of these things together are what we are searching for when we compete in the World Barista Championship. We can absolutely improve the taste of our espresso. And the thing is, like, obviously we're using a very good espresso, but it's a technique that can benefit all the espressos we've tasted so far with this method, which is quite astonishing.
Quite astonishing and quite surprising, but on the other hand, as you said, it's not such a surprise. It makes
It is not
sense.
such a surprise. Yeah.
But I was also curious. Why didn't we think more about the phase after extraction? We were so concentrated in preparing distribution, in dialing in the best shots. But this is actually something about post-extraction. So this happens when the coffee is already extracted. And what we find out also with some scientific measurements, espresso, coffee in general, is not stable. it's not stable in that moment when we extracted it. And it is an emulsion, but it's still not in a status of emulsion that it stays that way. It's changing. It's changing the whole time. And this is also something we saw using a microscope, that the particles all are changing. And to prove that, we asked some experts. In that moment when you told me, Ben, can you call me? Ben, can you come down? Let's taste together. I called Professor Chahan Yeretzian from the Zurich University of Applied Science. He's a professor in analytical chemistry and also guiding or leading the Coffee Excellence Center in Wädenswil. And then we talked a little bit about it, and he was also very enthusiastic because then he looked, is there already research on it? And he said, well, there is actually not a lot. There is a colleague, a friend of mine, Professor Stefan Salentinig from the University of Fribourg, who is doing some things in that direction, actually experimenting also with emulsions. Let's ask him. And then Professor Chahan Yeretzian made the contact. We met at the university to dig a little bit deeper. And I think we should ask these two to explain you what they found out, and also to ask them also to explain some of the findings which we tried to prove our hypothesis. I'm super happy to be here with Stefan Salentinig, professor from the University of Fribourg, and Professor Chahan Yeretzian from the Coffee Excellence Center in Wädenswil. Both helped us a lot with proving or analyzing some findings we had with empiric testing while vibrating espresso, because we changed our protocol. Instead of just steering, we found out that we have a totally different texture and also a different sweetness when we vibrated the coffee. And I was asking Stefan and Chahan, why did that happen? Can we prove it? Can data, can science help us to confirm our findings? And I think we found some pretty interesting things. Thanks again a lot to both of you for spending so much time with us, and also Stefan, to your whole team, receiving us, helping us, using all that fancy material which you have in your lab. I think this was amazing, and I'm super thankful for that nice afternoon which we spent together. What do you think? Did we have some findings? Can you say, or can you tell that the data is proving something of our taste results?
Yeah, so thank you as well. We had a great afternoon together, drinking coffee and discussing science and measuring a lot of cool stuff. So I would say yes. So what we saw with microscopy, with light scattering and other methods is that the distribution of particle sizes when you extract the coffee without shaking as compared to extracting coffee and shaking afterwards is quite different. So our indication is, or the conclusion from the data that we have actually with the light scattering, is that the particle size is different. That the particle size, of course, steers the texture, and this gives a different taste at the end.
Yeah, Benny, I think this is really a very interesting observation that Stefan could make. I remember when you called me and you said that you do the shaking and you have, like, sensory wise, you have a strong indication that makes real difference, And then the question is, we discussed what could it be, what could that be that shaking makes it better? And I immediately thought about emulsion formation, because everybody talks about emulsion in espresso. It could be that in this case, we are influenced emulsion formation just after extraction. And that's where I started to think, and I started to call around, because Stefan is one of these unique experts, in Switzerland, who has this experience in colloidal, in emulsions, and also understands coffee. And so as professor in physical chemistry at the University of Fribourg, I called him up because he's extremely well equipped to analyze this phenomenon. And so we did only half a day experiments, so to prove and to make it really solid, this requires more. But the data indicate that through the shaking, you create smaller particles in the emulsion, and that there is other papers that indicate that can have a significant effect on the sensory. It can also have an effect on the flavor retention, and many more things can come out. I think this is the start of an interesting phenomena where we might now discover emulsions, emulsion control, and emulsion measurements will be perhaps the big next thing in the future in espresso coffee.
Yeah, I think it was pretty interesting what we found out, and
You see the PDI,
Much bigger particles?
Yeah, 500.
500 and the PDI.
And the PDI is so big that you can evaluate with this device.
Okay, so this is now the first test. This would actually mean that it is really bigger, and
Why are they bigger?
because you didn't shake it.
Yeah.
Whereas the one that you shake, it
I mean, it's nearly the double.
Huh?
It's
Yeah,
nearly the double.
it's nearly double.
Something you always said or you repeated frequently was espresso is not stable after extraction. I think this is pretty much a very important summary of some of our findings, because stirring or vibrating changed the way the particles moved and kind of behaved to each other. Can we dig a little bit deeper into that? Why do you think is that the case?
Yeah, I mean, we have different. So what we saw is different populations of particle sizes. So different sizes of particles, let's say, in the espresso after extraction. We saw sizes of 300, 400 nanometers, so very small, which we think that it's oil bodies that are extracted from the coffee as emulsion particles. Then we have larger particles that go up to a micron, so the particles that you can actually then see with a microscope, because the very small ones are too small to be seen with a light microscope. You would need electron microscopy, and we use light scattering as a very beneficial statistical method, because it gives an overview over basically the whole statistics that we have in our volume that we tested was a milliliter of coffee. So we get a very relevant information on what is in the espresso in terms of particle sizes. And then, of course, all these particles move around. It's Brownian motion. You see in the videos, they are really alive in a way. And they collide with each other, and with time they grow, because these collisions can lead to a melting of two particles, or we have pressure differences, more complex things. But over time, the particle size grows. So the espresso changes over time. And we saw that this is actually quite fast. Within minutes or even sub-minutes, we see changes in the particle size and the distribution, which I think one can taste. I'm not that good in sensory, like tasting differences, but someone that is really well trained like you, I'm sure you tasted the differences as well then, that we saw, like with the more scientific kind of instruments looking at the meso and nanostructure as well.
Absolutely, the difference was absolute obvious and really easily not only recognizable but also repeatably. You saw it time over time, and after time it was always the same result. We feel that other texture, we feel that other sweetness, and the empirics, the sensory sides was pretty obvious. And it's really interesting to also find it kind of proven in the data. Chahan, you said maybe we have to look even more into the phase after extraction. We create kind of an emulsion, but maybe it's not in the status yet, or maybe we didn't research enough to about the part after extraction. Maybe we can go a little bit deeper into that. What do you think? What are the next steps? What do we have to research to understand even more what to do with an espresso after the extraction, and why is that the case?
Well, I think we did it quite fast, in the short time we had. But I really think the first element of research on emulsion is to develop instrumental, analytical basis, a platform to properly measure emulsions, emulsion size distribution, emulsion dynamics, but also the coating, because every particle, every fat particle has a coating which stabilizes. So I think we have a lot we can improve in terms of measurements. The second element that we need to understand is what should an emulsion be in order to have a good sensory profile. So first is measure. Then the second is where do we want to aim? And then the third trick is, how do we treat it? How do we go from where we measure to where we want to go? So this is, in fact, a huge new field for me, where a lot of experts like you have to define a little bit what really is an optimal situation, that we have to understand them also instrumentally, and then understand which type of treatment leads from where the espresso comes out to where we would like to bring it. We also would like to make it more stable. I think that this shaking or vibration could also stabilize the emulsion and keep it over a longer time. So there are many things. I think we're at the beginning, but really this concept of measure, aim, and treat is really what we have to do. And it's like the start of the era. Everybody tells espresso emulsion, but we know not enough. And I think you are triggering something. And it could be connected to many other things that people observe and never mention, We will find that out.
I'm pretty sure that this is a way to go. And when I now think back also about some espressos I drank in the past, I'm asking myself, was it really bad distribution? Was it really a problem of extraction, or might be the problem actually be the part or the time phrase after the extraction? Maybe the temperature of the cup, maybe not proper steering, or whatever. I think there's a whole world of things we have to look into, because this was pretty obvious. The coffee is not stable. It's not done yet. It's not finished till the moment you drink it. So I think we really have to look more and more into that phase. And I think all that questions we asked in the past, how long staying, how long staling, all these are questions we have to research again, not only by tasting but also by science. Stefan, I would like to go back a little bit. Could you summarize again which kind of machines did we use? And which machines gave some indications, and maybe which ones not. But I think this is also something really interesting for all the followers and people which are watching the video right now. What did we actually do after extracting the espresso? What was our kind of protocol which we used, and which kind of techniques did we use?
We started with microscopy. We did Raman microscopy, which is a very nice tool, because we can not only image kind of particles, at the same time we can get the composition of the particles inside and outside and different locations of the image. So it is a very nice compositional imaging method, so to say. But of course, it's optical microscopy based. So we don't see particles that are below, let's say, 500 nanometers in size. So what we saw is large, like emulsion particles floating around, oil inside, stabilized. We still have to figure out and analyze this in more detail, what the composition of the shell, of the core, of the outside is, and so on. And then to analyze smaller particles, we went to light scattering, which is actually very difficult in coffee because of the color, and we use lasers and so on. And it should not heat the sample as well, because otherwise we get artifacts. But we managed to develop a protocol that we could actually measure particle sizes in coffee. And we saw that the majority of the particles is actually smaller than what we see with the microscope. We see the same size that we see in the microscope, but then there's a population that is even smaller, which we assume is extracted oil bodies from the coffee, which would make sense. We saw this from other seeds where we can extract these structures, which are emulsion particles as well. So we have different populations, which is very interesting. Then we also did X-ray scattering. So we were shining X-rays on the sample, and it's an indirect method, analyzed the scattered X-rays. Also there we saw particles in the range of nanometers to micrometers. So very interesting data, different methods, all indicating, or all at the end showing within an afternoon that we have particles, that we have emulsions in the espresso after the extraction, and that this changes because we did time-resolved experiments, so at different time steps after the extraction, where we actually saw the change in particle size that you mentioned before. which is also very interesting to discuss and to analyze further, of course.
Yeah, and we looked into the differences of not steering with a spoon, vibrating, and then we used even ultrasound and 2 different methods of ultrasound. We saw also something there, but then we interpreted again that this might be also the gas, the CO2 brought into the solution. Or could you summary for me the results which we found by ultrasounding?
Yeah. So what we did is with this ultrasonication, with the ultrasound, is basically we bring in a lot of energy into the coffee. And this energy, of course, disrupts particles. It mixes the solution, but it also disrupts particles, larger ones, and makes smaller ones out of the large ones, because you basically have an emulsion that has a certain energy. The droplet is oil, like floating around a certain size. And then you put a lot of energy in, and this particle breaks up into 2 or 3 or even more, depending on how much energy we bring into the system. And with our high energy sonication, we completely changed the texture and the sensory properties of the coffee as well. And we saw with the analytical methods that we changed the particle size, as we hypothesized before we started the experiment, because we said, okay, if vibrating gives a certain energy, what happens if we increase this energy and basically go brute force with this ultrasonication device?
Yeah, and we drank a lot of coffee. It was a nice afternoon. Many people of the university, of your faculty, came around to have an espresso. So we enjoyed also the afternoon. I think also this is a reason to continue with that research, so that we have some nice coffee together. Can you give some hypothesis? Where does it lead to? What do we have to figure out next? What could be the next steps? Maybe some ideas in that direction.
Just first of all, I think we had a hypothesis, and it seemed to be correct. Of course, it's only half a day experiments. We did that, so we see that the shaking leads, or the steering, or then the intensive shaking gradually decreases the size of the smallest nano-sized particles, which we assume are fat globals, emulsions. So, and that would indicate that in the mouse you get another feeling, and we saw that, and so that's very interesting. And the second for me is, as what you said already earlier, Benjamin, is that we are kind of shifting our focus to post-extraction phenomena. We have spent so much time trying to understand the extraction, and there is a lot happening post-extraction. And so we have introduced other tools and observed other phenomena. And I think it's interesting to see that, again, after extraction, there's a lot happening, and which can improve the quality of espresso. I think that's my takeaway.
From my side, I fully agree. The very interesting part is this link between composition at the end that you get in the coffee, and then we have a structure, and then we have sensory properties. No? And here we have the composition is the same. The composition does not change when we change the particles, or when the particle sizes change over time. It's the structure that changes on the micro scale, on the nano scale, and that gives completely different properties, sensory properties. And this is not analyzed at all. This is a field of research that is just starting, because traditionally everything is based on composition, but now we more and more realize that the structure plays a role, and the structure, even at the larger, not only macroscopic, microscopic and nanoscopic, is important in this sense for physical properties and sensory properties. So that was very, very nice to see with the coffee experiment.
To both of you, I think I'm super thankful. I think the whole coffee community is super thankful. And I know that there are many people in the coffee community which are also interested in science, but also in chemics and physics. So I like to invite you to use that window to do a little bit of propaganda for your faculty. What are you both doing? If someone likes to combine studying and researching and coffee maybe in the future, why should they apply in your university, or what offers you in university? Stefan, you like to start?
Yes, I mean, to start with, we are fascinated and we become more and more fascinated about coffee. Also with you and your input and all the kind of new work that we get linked to now, where we can use our tools, where we can use all the physical chemistry and the equipment, the fancy equipment that we have to analyze things that no one else analyzed and saw before. And that's what we are passionate about, emulsion, stability, things that are very small that you cannot see, but that have a huge impact on properties, on taste, on materials, related to coffee, related to food in general, nutrition, all the flavor compounds that are released depending on size of particles, structure, and so on. And you can actually feel it, you can taste it. That's the amazing part in the coffee world. And it keeps you awake as well.
Keeps you awake. And also Fribourg is a beautiful city. I will link your university down below the video so that people find you and your work. Thank you so much, Stefan. Chahan, you are already researching many years with coffee in the Coffee Excellence Center. I'm pretty sure most of the people know you, know your work, and also the ZHAW. Nevertheless, if someone doesn't know about you and your work, what should they know in the future?
We are a center dedicated to research on coffee along the whole value chain, from sustainability project, emerging countries, all the way to coffee tastings and everything in between. Because the special thing with coffee is that everything is connected. You cannot really understand extraction if you don't understand coffee origins or the sensory. You have really to connect everything to understand even elements. So the zero thinking is not something we should which is very helpful in coffee. And so that's one of our objectives. And we work with a lot of companies worldwide. And I think we have. I'm just one person in the Coffee Excellence Center. We are many people who are doing excellent work over the many years, and we also over the last, I would say, 3-4 years, have realized that research is important, but education is actually also very important. People now are asking more and more about education programs of things that we already know since a long time, but which is not disseminated. So we are now pushing education program postgraduate degrees. To answer also to Stefan, I think an element that is neglected is definitely this texture of the structure. People always connect composition to properties, because it's like you look there where you have techniques, But another field that we worked recently, and it's like a video into a paper that will come, is roasting. Roasting depends very much on the bean structure. We always research on the composition, on the precursors and the roast profile. But if you grind the green coffee, you get a totally different flavor profile. The texture is fundamentally important because of the microreactor composition. And so we did a whole project on different rice, different, like very coarse to very fine, and looking at the formation of flavor. So I think that's another takeaway. And I think with people like Stefan, texture in coffee is a very important element, neglected. And perhaps also because we don't have yet the experts in the techniques. I don't know. And that could be also something that I would like to further pursue with Stefan in the future. I would like to wish you a lot of success during the World Championship with all your knowledge, expertise, and I think now more than 10 years or 15 years of experience in this field, in the world of specialty coffee. You deserve it to really perform well. I will be observing, watching from far, and I wish you all the best.
Thank you so much, Chahan.
Hey, I wish you all the best too. I hope you manage to pick it out.
Isn't it crazy? We all love espresso, we all love coffee. We are testing so much, and now a new world is kind of opening itself, the phase after extracting. I'm so curious because there's so much to do still, so much to research. How many times shall we wait? How many vibrations shall we give in? How many ultrasonics or whatever systems shall we use to make coffee more stable? Or maybe it's also interesting to have it not too stable sometimes because we want certain changes also in taste over time. I'm super happy that you opened that door for the whole barista and coffee community. And I also like that we decided against doing a patent or something. We wanted to spread that knowledge and open it for you to experiment with it. So my idea and invitation to you, look around, maybe you find something vibrating in your household, use it and vibrate your espresso. You will be absolutely flashed about the results. Meanwhile, Felix is presenting on the stage. Good luck, have fun, and
Time.